Where we left off, talked about while loops. We've actually been using loops for a while, I believe. No pun intended. We're going to talk about a couple of different kinds of loops today. And then if we get past all of that, we're going to talk about using files. Seems a little early to begin using file I/O, but that's the way the book is arranged, so we'll hit it. Along with while, there are do-while loops. Sounds similar, and that's because they do similar things, but not exactly the same. And let me show you what I mean. You don't need to type this in, I'm just typing notes. So, here's the way a while loop works. We're pretty familiar with it by now. What would this print out? You know what, I'm just going to make it like our other ones where we start off like at 1 or something and we go less than 10, that kind of thing, you know. Alright, so what's that going to print out? Y'all are awake, somebody tell me. 1. Yeah, it's going to print 1 followed by a 2, 3, 4, 5, 6, 7, 8, and 9. Alright, so if I'm going to lower that number to x is less than or equal to like 4, so I don't have that many numbers here. So it would print 1, 2, 3, 4. While loop looks very similar, and in many ways it is. Here's how we would write that one. Y is equal to 1, while y is less than or equal to 4. Nope, I said we're going to use a do while loop. So do this stuff while y is less than or equal to 4. Again, we're going to see out, y, NDL. I guess we could have actually typed this in as C++. And then y++. This is going to do the same thing. Y starts at 1. We print out a 1. We add 1 to y, and then we check. Is y less than or equal to 4? It sure is. So at this point, y is equal to 2. So we come back, we loop again, we print out 2. Then we add 1 to y, so y becomes 3. Is 3 less than or equal to 4? Sure enough. So we come back up to the top, we print out 3. We add 1 to y, it becomes 4. Is 4 less than or equal to 4? Sure is. So we loop once more, we print out 4. We add 1 to y, so y is equal to 5. Is 5 less than or equal to 4? Nope, so we stop. So these look like they did the exact same thing, right? They printed out 1, 2, 3, and 4. But a while loop is known as a pretest loop, meaning that the test happens before you go into it. What if x was equal to 10? Would it print anything? It wouldn't print anything because x is not less than or equal to 4. Down here, though, does something. Let's, I'm just going to copy that so that, you know. So x is equal to 10, while x is less than 4, doesn't print a thing. Because x is not less than or equal to 4, and this is a pretest loop. Test happens before the body of the code. If the test fails, we fall through it. We don't do it. Now I'm going to steal this code and replace it with y is equal to 10. What does it print? This is a post-test loop. The test doesn't happen until the body of the loop has already been executed. So y is equal to 10. Do this. Print out y. All right, I'm going to print out a 10. Add 1 to y. Y is now equal to 11. While y is less than or equal to 4. Is that true? No, it's not. But it did print something. Whereas this one didn't print something. It's like there's nothing you can do. Almost sounds like a Beatles song. There's nothing you can do with a do loop that you can't mimic with a while loop. But good question, and we'll get to it. You use this when you want to make sure that the body of the code is executed at least one time. Up here, use a while loop if it's okay for the body of the loop to not be executed. So let's do an example of that. What if we did this? Cout, enter a number or -1 to quit. And then you did this, while, well, we haven't read it in yet, have we? Cin into x. While x is not equal to -1, do something with that number. Who cares what it is? Cout, the number is, followed by x. All right, so it's going to print it out. Maybe we ought to actually be entering this into our code. I think we ought to. This is not going to be a good example of why you should use one over the other, by the way. We'll step through the PowerPoint in just a minute to make sure that we do have a good example. The books suggest that menu-based programs be implemented with do loops rather than while loops. But like I said, honestly, you can implement anything with a while loop that you want. Sometimes the logic is just a little bit more convoluted. So I created a new project, Solution Explorer, right-click, do add, new source file, C++ file. Going to add some boilerplate. I'm not going to even include stream, pound include string, pound include cmath for the Mac users, and then we're not going to do using namespace. We're going to use std::. If you feel rebellious and feel like doing using namespace, go for it. So int main, return 0. Mac users can skip the system pause. Alright, we ought to be real good at typing that, and if you have it copied and pasted, I certainly do not blame you. Alrighty. So cout, enter a number, \n. But I can't use cout because I didn't do my using namespace std, so I need to preface cout with std::. Now let's declare a variable and read into it. Int x, guess we ought to make it a double in case they type in a decimal point, but who cares. And then cin, arrow into x, but since this is going to start annoying me, std::cin, arrow x. And then we do this, while x is not equal to -1, and I forgot to put that as part of my message here. I'm going to go back and add that. Enter a number or -1 to stop. I'm going to break it up into 2 lines. You certainly don't need to. Okay, so while x is not equal to -1, cout our number. Your number is, and again I need to do std::cout. That's really going to get annoying. Your number is, end quote, and a couple more arrows, followed by x, followed by std::, e and dl. Now, if we're going to keep looping, we need to ask them again. We need that same information. std::, cout, enter another number. or -1 to stop. /n, end quote, semicolon. And read that in again, std : cin into x a second time. All right, now we have a handy little loop. Reads in a series of numbers and prints them out. We could be summing them or multiplying them or, doing menu based, something like that. All right, I'm failing to see why rewriting this as a do loop would give us significantly different behavior.
Well, if you had call a function whenever you insert a menu, is it possible that a required function could be pulled with that do statement versus?
Yeah, if we were going to write this differently, we might do this. We might not offer them the option of doing a -1 to stop for the first iteration. Let's go ahead and look at their example because my brain's being a little bit fuzzy. All right. So the syntax of it is do followed by a statement, which could be a block, while expression. The logic of a do loop. You CIT1173 users never had to flowchart a do loop. But you see the statements get done first and then the decision happens. And then it loops back and runs those statements again. The only reason we didn't flowchart a do loop is because they didn't exist in Python. So the loop always executes at least once. The execution continues as long as the expression is true. It stops repeating when the expression becomes false. Useful in menu-driven programs to bring user back to the menu to make another choice. See program 5.8. All right, everybody open your book and see program 5.8. I wish I had the text of the program here. Thanks, guys. Let's ask Google. When to use a do while loop? It is possible and in some cases desirable for the condition to always evaluate to true, creating an infinite loop. Yeah, so what? All right, demonstrating do while loops. That doesn't explain why to use one. It's just a whole bunch of different ways to write it. Hey, they do say that there's a way to do it. Python lacks a specific do while structure. However, you can use a while with a break. And we have done that. That was a bust. Why would you use a for loop instead of a while loop? What's a good reason to use a do while loop? The do while loop ensures that the body of the loop executes at least once. I wrote a lengthy response to a question regarding the differences between while loops and do loops. Perhaps you've written a graphical... All right. I think I'm just going to punt on that one and say if you ever come up with the idea that you actually need to execute the body of the while loop at least once no matter what, that's about the time you start thinking of a do loop. And probably the reason I'm failing to come up with a great example of it is because I never used them in my coding practice because I could always rewrite it with a while loop. I'm trying real hard to come up with a good way of doing a do loop. What if we wanted them to make sure that they actually did enter at least one data? And let's do it this way. Let's go back in and we're going to, not Java. We're going to write the same kind of code here, except we're going to add up numbers. So int total is equal to 0. And then do this stuff. Standard : cout. Enter a number. std colon colon cn into x. Let's add x to our total. Total plus equals x. Now let's ask them if they want to repeat. std colon colon c out. Do you wish to repeat? One equals yes, 0 equals no. Let me break that into 2 lines. So then we're going to read back into std colon colon in, std colon colon cin into x. And we're going to keep repeating. So end brace while x is not equal to 0. This is kind of a legit way of using a do loop. It's not using a Sentinel value though. But we know we want to at least add one number to our total. If we were going to do this with a while loop, it would look a little bit different. And what do I mean by that? We probably would need a priming read. So after you've typed all this in, oh, you know, heck, we ought to run it too. Make sure it works. I'll bring the code back up in a minute. All right, 100, you typed in 100. 200, you typed in 200. -1 to stop. Enter a number. 10, do you wish to repeat? 1, yes. Enter a number. 20, do you wish to repeat? 0, and it stops. So it's behaving as we expected. What's the advantage of doing it this way as opposed to doing it this way? Here we asked for the input twice. This is what's known as a priming read. The priming read is a read outside the loop. And then we have another read inside the loop. Here, we don't have a priming read. We only enter it once. And yeah, we had a Sentinel value, but we could fix that if we wanted to by using an if statement. I vote we do that. Enter a number or -1 to quit, like that. So I'm changing my first cout statement. And then I'm going to add another statement underneath it that says if x not equal to -1, do all this stuff. Like that. So I'm making some changes, and I hope I'm not making it too hard to follow, but hopefully it won't be. And this last one needs to be x not equal to, tell you what, let's change the -1s to 0s. Enter a number or 0 to quit, and if x is not equal to 0, do that. Add it to our total. And then keep running while x is not equal to 0. That looks very similar to our other code, but it doesn't have a priming read. We didn't have to have a read before the loop even began. So, I try to avoid priming reads. I don't like having duplicate chunks of code. In our while loop up there, we had enter a number -1, and then that was before the while loop, and then inside at the bottom of the loop we had it again, enter a number -1 to quit. We had two different, we had duplications of code. And what if that code was more complex than just a CIN and a cout statement, a pair of statements? What if it was anyways. So I prefer to write my code in such a way that there's no priming read. But as I said, anything you write with a do loop, you technically could write with a while loop as well. I would write this as a while true loop, and then after I ask their number, I would do if x is equal to 0, break. Would do the same thing. Don't know if that helped at all. At least it kind of circled the issue. Did it kind of help? All right. Hopefully you see the structural difference though. Here, this is a post test, so it does all of this before we even check. Here, this is a pretest, so it checks it before it comes in here and runs it. We're getting to the good loop. The for loops are the good loops. The for loop. The for loop is the best loop. It's the one loop to rule them all and in the darkness bind them, for you Lord of the Rings fans. Useful for counter-controlled loops. But it's actually useful in a lot of places. The general format. For initialization, semicolon, test, semicolon, update. Now these are all things that we get to fill in. Like the initialization may be for int x is equal to 0. And the test might be, or let's make it duplicate our notes. For int x is equal to 1, our test is x is less than or equal to 4. And our update is x plus plus, like that. And our statement is cout x. All right, good enough. Okay. That's pretty short, isn't it, compared to our while loops previously? It's only 2 lines long, but it does the same exact thing as our while loop did over here. Here our while loop looked like this. We initialized x to 1. We had the word while. We had some processing of it, and then we had our update. So I'm going to copy this yet again, come down here and paste it. Well, heck, let's put it into our code now. So above our pause, let's declare a new variable, z, I guess. Int z is equal to 1, while z is less than or equal to 4, curly brace, standard colon, cout, arrow, arrow, that number, z, and then arrow, arrow, std, colon, endl. And if you really are tired of typing std, colon, colon, feel free to go back and add using namespace std up at the top. And then we incremented x by 1. Excuse me, z by 1. We're going to rewrite this as a for loop now. For, but I'm going to pick a different variable name. For int a is equal to 1, a is less than or equal to 4, a plus plus, std, colon, colon, cout, arrow, arrow, a, arrow, arrow, std, colon, colon, endl. So check it out. If you ignore the braces, this took 4 lines of code and this took 2. The syntax is much more concise. So if we were going to put labels on it, this z is equal to 1 is the initialization step. This is the comparison check, the condition, and this is the update, right? All 3 of those things. A for statement consists of all 3 of those things in one header line. It's got for, and then it's got an init state, followed by a semicolon, a condition, followed by a semicolon, and an update, followed by a semicolon. Again, is there anything you can do with a for loop that you can't do with a while loop? No, but the syntax is very clean and precise. Just like in Python, when we used the for range, or we did the for in list syntax, you could have done that with while loops, but it was a lot more convenient to do for x in range or for x in list. Same deal here. The syntax is just a lot more concise. So let's write a loop that'll add up all the numbers between 1 and 10, our favorite behavior. Total is equal to 0. For, again, I need a counter variable. I guess I'll use c this time. I could reuse a. For int c is equal to 1, c is less than or equal to 10, c++, total plus equals c. That would have taken longer to write with a while loop, right? We would have had to initialize C in one line. We would have to have while C is less than or equal to 10 on another, and we'd have to have the update at the bottom. I haven't run it in a while. Guess I oughta. -1, 0. All right. Print it out 1, 2, 3, 4, 1, 2, 3, 4. Didn't print out our total, but whatever. C out total was, or a total of 1 to 10 was. So STD : C out. Arrow, arrow. Total of 1 to 10 was, followed by our total variable, followed by STD : ENDL. Just so we can keep track when we look at it, what it's doing. So those are really it. While loops, do loops, and for loops. When do you use each one? I'm going to start a multi-line comment. So /*. Use a do loop if the body of the loop must be executed at least one time. Use a for loop to count, to iterate over a series of values. Use a while loop otherwise. So for example, when you're asking the user for numbers and then, and they enter a number and you have a guessing game going on and you don't know how many times it's going to take for them to guess, would you use a for loop for that? Pick a number between 1 and 100 and you guess 50 and it says, no, it's higher. So you guess 75 and it says, no, it's lower and you guess 60 and it says you got it. Would you use a for loop for that? Does a for loop look suited at all for that kind of business? Now, just the way I ask that kind of gives you the answer, but I'm going to stare at somebody until y'all give me the answer. Yay, I see some people shaking their head no. Could you write it in a for loop? Yeah, but you wouldn't. You would either use a while loop or a do loop. Use a do loop if the body, I always use while loops, honestly, rather than do loops, but that's the book definition for when you use a do loop. Use a for loop if you're counting over a series of values. Going from 1 to 10, 20 to 100, you're going to iterate over an array or a list. For you guys who have already taken classes where you used arrays and lists, those are when you use for loops. Notice if you, just like the if statement, if you put or a while statement, if you put a semicolon there, it'll break your code. Won't do anything. We could prove that. Let's go here and go to one of our for loops and put a semicolon there. Boom. It doesn't work anymore. It gives us an error here. Why is that? Because this is the same as, and I'm going to undo all this so you don't really need to type it all. This is the same. Putting that semicolon there is the same as doing this. For C is 1, C is less than 10, C++, do this. Big whoop, it does nothing. Then it comes down here and it tries to add C to the total. Well, C doesn't even exist anymore. It only existed inside those braces. So, just like with if statements and while statements, I'm sure that when I'm wandering around trying to help people, somebody's going to have a semicolon in the wrong place. You're going to have it there. Your general rule of thumb is anytime you have an opening brace, there should not be a semicolon on the line before it. It's true for if statements, it's true for while, it's true for, it's true for do, it's just generally true everywhere. For loop mechanics. There's the initialization, the test, and the update. I was calling it the condition, the test. The syntax, the order in which these are done, a little bit weird. But it does that first. Then it does that. If the test is true, it runs the body of the code. Then it updates it, and it tests it again. Just like our while loop had a condition up at the top, right, and then you ran some code, and then it had an update, you know, x++ at the bottom of it. These execute in the same sequence. Initialization, do your test. If the test is true, do your block, then do your update, then repeat your test. Just like that while loop. That makes it sound harder to understand than just when I said, you know, x is equal to 0, x is less than 10, x++. You just understood that right away. Right, saying it in the long form about the order in which they go is just a little bit more complicated. You already know how it works just from the 2 times we've demonstrated it. Here's our for loop sample. Count is equal to 1, count is less than or equal to 5, count plus plus. How many times will that print a number? Well, it will print a 1, it will print a 2, it will print a 3, it will print a 4, and it will print a 5. Yeah. If it had said count is equal to 1, count is less than 5, and then I asked you on a quiz, how many times is it going to print hello? You might look at it and say, oh, it's going to print 5. But it's not really, right? Because it's going to go 1, 2, 3, 4, but it's going to stop at 4. Because once count is 5, 5 is not less than 5. So it would print out 4 times. Flowchart for the previous example. And I draw these flowcharts completely differently for for loops. So those of y'all who took my 1113 class may look at this and go, what? But anyways, assign 1 to the count. Count less than or equal to 5? Yeah, if it is. Do your statement, do your update, then come back and do your check again. If the condition is still valid, your test is still true, do the statement again, the block of code, do the increment again, and come back. Now what makes for statements a little bit weird? And so you'll see people do all the funky things with them, is that you can leave out the parts between the semicolon. If you don't want to initialize a variable there, you don't have to. You could delete that. It better be initialized somewhere else, right? But if you want to initialize it but you don't want to put your test in there, you could take that out. You better have a break statement though, right? Or else it'll never leave. If you feel like not doing your update in there, you could take that out. And again, something had better change X or else it's an infinite loop, but you could do that. If you feel like being totally weird, you could do this, and that's the same as a while true loop. Am I going to recommend you do those things? Not really. As you see other code out in the real world, you may see times when they've eliminated some of the clauses here. I'm not going to bother trying to come up with examples of when you would do that. Nope. Not going to do it. So they wrote a for loop that would print out this table of squares. Print out the number and then print out the number squared. Let's do that. So int, no, let's declare it inside our variable. N for number. Int n is equal to 1. N is less than or equal to 10. N plus plus. And inside our code, std : cout, let's print out n, followed by a tab character, so arrow, arrow, \t. Followed by another arrow, arrow, and let's print out n times n. Followed lastly by an endl. Arrow, arrow, std : endl. That'll print out our table of squares. That's why I try to avoid doing demonstration programs that require you to type numbers in, because as you run it more and more, you get tired of entering the test data. Okay, so it printed out our table of squares: 1 to 10, 1, 4, 9, 16 to 100. So here they write it a little bit more generically. They have a variable called minimum number. Where are you going to start counting from? And then they have another variable called max number. So instead of going from 1 to 10, maybe you want min number to be 100 and you want max number to be 120. So it would print the squares of the numbers 100 through 120. So when to use a for loop? In any situation that clearly requires an initialization, a false condition to stop the loop, and an update to occur at the end of each iteration. Now, that actually covers the vast majority of our while loops that we've written up to this point, with the exception of the ones with a Sentinel value where we broke out of it if they entered a -1. We have done that, right? We've used that -1 idea before. Okay, good. But anything you could use a for loop for, you could use a while loop for. Anything you could use a while loop for, you could use a for loop for. They are absolutely identical in terms of functionality. It's just that the syntax is a lot cleaner for a for loop. So my rule of thumb is if you're going to process over a counter or a sequence of values, a for loop is perfect for that. Just like a while loop, for loop is a pretest. For loop modifications, you want to initialize 2 variables, you can do that. Kind of wondering about something there. Let's play with that idea a little bit. For int j is equal to 1, comma, k is equal to 2, semicolon, j is less than or equal to k, semicolon. Can I do j plus plus, comma, k minus minus? I'm not sure that it's going to accept that syntax. It did. So then let's just print out j and k. Standard.c out j, followed by a space, followed by a k, followed by std:\endl. std:\endl. That's totally legit syntax. Our initialization step is just a little bit more complicated than it was. Why did I put k as less than or equal to k? That's always going to be true, is it not? K is always equal to k. I meant j less than or equal to k. How many actually typed j because you knew what I wanted? Yeah, you're psychic. Okay, here we go. Should have been j is equal to 1, k is equal to 2, semi. And I also don't want to set it equal to 2. I want to set it to a high number. How about 100? And then as we run it, j is going to be increasing and k is going to be decreasing each time because of the update step. Every time we're done with our loop, after one iteration of the loop, add 1 to j, subtract 1 from k. Eventually we're going to get to the point where j is no longer less than k, and that's when it abandons the loop. -1 to stop, 0 to quit. And there we go. It printed all the numbers between 1, 100, 299, 398, 497, all the way up to 50, 51. After that, j was no longer less than k. On the next iteration, j became 51, k was equal to 50, so j was no longer less than. How many times do I take advantage of the fact that I can initialize more variables than one there? For one thing, that's not even possible in certain other languages like Java. It's supported in C++, not Java. Same for this update. I do not believe Java supports that syntax. Now for you Python guys, you'll notice that this is a little bit more You also couldn't do anything like that in Python, right? This you could. And you non-Python users are saying, why in the world are you even talking about it? If you wanted to write this loop in Python, you would do this. For n in range, starting at 1, going up to 11. Why 11? Because you got to go 1 past that number there, comma 1. That's the same syntax in Python. Start at 1, go up to but not include 11, adding 1 to it each time. Same idea. But you couldn't do this business with it. J is equal to 1, K is equal to 100. Add 1 to J each time, lower K by 1 each time. You couldn't put some weird case here that would cause it to quit at a certain time. You know, why? While J is less than or equal to K, or K is equal to 50. You know, keep running. Because this expression right here could be very complex. So C++ is a little bit more, I won't say capable, but its syntax is freer in some ways. So we've seen that you could have multiple initializations. You just separate them by commas. You could have multiple states, questions in the test expression. The one thing you can't do is have multiple conditions. You can't just start chaining conditions with commas there. If you want multiple conditions, you have to combine them with ands or ors. You can omit the initialization step if it's already been done. Since num has been set to 1 here, we don't have to do it here. I'd rather do it there anyways, right? Really, honestly. I'd put that there, like that. I don't see any advantage to leaving it off. But you could. Same with that. You could leave that off if the body of the code included a num++. But by the time you're doing that, it's starting to look like a while loop again, right? If you do this, num++ there so that you can take it out, lo and behold, it looks exactly like a while loop. I don't see any advantage to doing that. You can declare variables in the initialization expression. That's what I've been showing you all along. Actually declaring the variable. If you do that, then the scope of the variable is within the body of the loop. What do I mean by that? Well, here I declared something called J and K. Can I access those variables later? Can I say J is equal to 100? No. That variable only exists inside that loop. That's kind of nice actually, because you can declare your variables here and then not have to worry that you're overriding some other variable here. What if I do this? Double J is equal to 100.1. And then underneath all this, I do cout J followed by an N, DL, and of course I have to go in and add my STDs here. Sounds bad. STD colon colon, like that. J at this point is still going to equal 100.1. By declaring my variable inside the for statement, and this is actually something that a while loop can't really do in the same way. So this is one advantage to a for loop. When I said there's nothing you can do with a while loop that you can't do with a for and vice versa, this is actually an argument in favor of for loops. Because no matter what happens to this J variable here, this one stays the same. So when you create a for loop and you declare it like that, you could declare your variable and you don't really have to make sure you haven't used that variable name before. Not sure if that makes sense. I hope so. I better run it to make sure it equals 100.1 after all of that babbling about it. -1, 0. Yeah, still equals 100.1. Keeping a running total. We've already learned how to do this. To keep a running total, your code has to initialize a total, an accumulator up at the top. You're going to add up scores. You're going to add up, rainfalls. You have to have something up at the top. Then you can have your loop, whatever your loop is, while blah, 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 and then you start adding something to the total, right? That's your running total. Whatever your while clause is, whatever you're adding to it, whether it's something the user types in or whether it's a part of a series of numbers, that's your general thing. You declare your accumulator, fancy word, and you modify your accumulator inside the loop. That's the general syntax for a running total. Whether it's a while true or whatever else. And the loop could be something else, right? It could be a for loop, it could be a do loop, whatever. That's just the prototypical, that's how you conceptually think of a running total. You often declare, a counter or something as well if you're writing a while loop. If you're writing a for loop, you don't have to declare your counter up here along with the total. So a running total is something that's an accumulated sum of, I think I said that wrong, accumulated sum of numbers from each repetition of a loop. And the accumulator is the variable that holds the running total. So here they go. They declare a accumulator called sum, and then they have a counter variable called 1, num. Sum and num, those rhyme. Sum is your accumulator, num is your counter. And then while that counter is less than or equal to 10, you keep adding it to sum. And then you increment num. Be easier to write with a for loop. Take fewer lines of code. If I was going to rewrite this as a for loop, I would do, let me copy that and paste it in a notepad, but then rewrite it. Int sum is equal to 0 for, what's going to be first? I need to initialize my counter, so what's that going to look like? Deafening silence. I know somebody knows. How have all my for loops looked? I had the word for in the parentheses, and what was the first thing after that? Come on, guys.
Int.
Yeah, int, and then the name of our counter. And I'm going to initialize it to what? Same thing here. Int num is equal to 1, semicolon, and the next thing is my condition. So what's my condition going to be? Yep, numbers less than or equal to 10. And then finally my update, num plus plus. And then inside the body of my code, I could use the braces if I wanted to. I could leave them off if I felt like it. I'm going to go back and add the braces. There we go. That's the same code as this. Which one do you like better? How about you? You tell me which one do you like better. You like while loops or for loops better at this point? There's no wrong answer.
I think for loop.
I like for loops better.
I like for loops.
Yeah, you chose the right answer because you heard me say it. No, I'm kidding. I'm kidding. Yeah, I think for loops, the syntax is more concise and clean. Whenever I'm typing demo code up here, I almost always forget to increment if I'm doing a while loop. And then I go, and then I have to edit it, and I have to go back. I never forget my incrementer, my update statement for a for loop. Alrighty. Logic for keeping a running total. You initialize your accumulator, you go in some your value. Is there a number to read? Sure is. Read it, add it to the accumulator. So you could do test scores or bowling scores or something like that. Sentinels. A sentinel is a value that indicates the end of data. So it's a special value. Enter test scores or -1 to quit, because hopefully your students aren't going to make a -1 on their exam. If so, you're a really mean teacher. So it's a special value that cannot possibly be confused with a valid value. -999 for a test score. Okay, that'd work too. It's used to terminate input when the user may not know how many values may be entered. I wouldn't say when the user doesn't know. It's when the programmer doesn't know. You don't know how many test scores they're going to enter, so you can't write a for loop to do it. You can't use a counter to do it if you don't know how many test scores there are to begin with. So instead you use a Sentinel value. You let them type it in. Why would you use a Sentinel value? There's more than one way of doing it. You could write your program so that it'll look like this, right? Enter test score. You typed in 100. Do you wish to add another y/n? And they type in y. Enter test score. Question mark. You type in 90. You get the idea. Do you wish to add another yn? You type in a y. I'm going to do some cutting and pasting because this is getting tedious. Enter your test score. They made a 95 for the third exam. Do you wish to add another yn? They type no. And then it would say the total was equal to 200 and whatever that is. $285? Yeah. 275. 85. Yeah. All right. So you could write it like that, or you could make it do this. Enter test score, or minus 999 to stop. They type in 100. They type in 90. They type in 95. And then they type in negative 99, 999. And then it prints out their total. If you were a data entry person being, paid by the hour to type in stuff, which one would you rather do? Enter test score, do you wish to do another? Yes, no. Enter test score, do you wish to do another? I wouldn't want to have to keep switching between, the numbers and the letters. I'd like to just be able to use my numeric keypad or whatever. This is called using a Sentinel value, and this is called using a user query. So these are loop termination techniques. This is user query, asking the user if they want to stop. And this is another loop termination technique. Hope that makes sense. I vastly prefer that one, so I tend to demonstrate that one all the time. About the only time I ever use this one is like if you're doing something that requires a lot of steps. You're playing the guessing game. I'm thinking of a number between 1 and 100. Guess. 50. Nope, that's not right. Guess again. 95. Yeah, you got it. At that point, it's fair to ask, do you wish to repeat, right? So a user query there would be a good thing. But just for entering a series of values, that'd be a real drag. So a Sentinel value is used to terminate input when you don't know how many values will be entered. Deciding which loop to use. They don't even show a demo. Yeah, I guess they did. Here's how they did their Sentinel loop. It uses a priming read, which I've already mentioned. So enter the points for the game. CIN into points. While points is equal to -1, you add it to the total, and then it asks for the points again. But you said that they could enter -1 to stop. So they read it in again. As long as the points that they typed in is not equal to -1, we keep repeating the loop, and then we're finally done. So to implement a Sentinel value requires either doing a priming read or a little bit of logic in here. And that little bit of logic could be using a break statement, or it could be using an if statement to skip the code if they enter the Sentinel value. So this is going to be the last thing we do. Let's go ahead and write some code that does something similar to that and supports a Sentinel value. Keep loading up Java. So let's declare a total score. Initialize it to 0. But I don't want to use a priming read. They're just against my religion. So I'm going to declare a variable called score. And I'm going to set it equal to a valid value. I don't want to set it equal to an invalid value. And so while the score is not equal to, and what's our Sentinel value going to be? -1, that's my favorite. The book recommended -999. Okay. While the score is not equal to -999, let's ask them for the score. Standard : Cout, enter score, or -999 to quit. \n. Now let's read that score in. std : cin, .. score. But we have to make sure that we have a valid score. So if the score is not equal to -999, then add it to our total. Total score plus equals score. Like that. Now we've got a Sentinel loop there. I tend to write these with while true statements, actually. So we're going to rewrite this using a while true. Total score is equal to 0. While true. Standard.cout score, or -1 to quit. Just changing it up for no good reason. Read it in. std : cin, .. into the score variable. And if the score is equal to our Sentinel value, if parentheses score is equal to -1, then break. Break our loop. We haven't hit break in the PowerPoint slides, but hopefully we know what it means. And then total plus equals score, like that. I don't know which of these look better to you. Both of these are totally valid ways of doing it. To get all the code to appear on one screen, I'm going to start moving braces around. See if I can get them all to appear on one line. There we go. Like that. You don't have to tell me that you have a preference for one or the other. I forgot. Yeah. So, 2 ways to implement Sentinel loops. I like this one. The reason I like this one is I don't have to initialize my score variable outside of the loop. I could have declared it inside the loop. That's fewer initializations I have to do outside the loop. If I do a Sentinel loop with a while true, then where was I? I spaced out. I don't have to initialize my score variable outside the loop. I can only do it, I can do it inside the loop. And to me that looks cleaner if I had done that, if I'd put int score is equal to 0 inside the loop. Now the textbooks would all show you using a priming read for this, where you'd ask them for the score, then you'd have a while loop, then you would add it to the total, and then you would ask them again.
Does that need to be total score or total?
I am so sorry, pardon?
Should that be total score or total?
It should have been total score, you're correct. Now my code's kind of silly because I'm not keeping track of how many scores. We could add another variable called count, and we could increment it every time we add to it. We'd have to do it for both of them like that, but I'm going to leave that alone. All right, that's about enough. Let's go look to see if we have any homework waiting for us. Nah, nothing that's looking really good. All right, we're going to make one. C++ over loops. Write a do loop. Nah. Write a while loop that prints all the numbers between 1 and 20. Write a for loop that does the same thing. And then write a while loop that prints 10, 20, 30, 40, 50, up to 100. Write a for loop that does the same. And then since we haven't done a while loop yet, write a while loop that prints 100, 90, 80, 70, down to 10. Except write a do loop. That's what I wanted that last one to be. So just a couple of loops. Probably won't take you more than 5 minutes. Or if it takes longer, that's fine. If you get stuck, ask me about it. That makes sense? Pretty short assignment, guys? Alrighty. Let's make a Dropbox, and we can be done for today. So this will be in. Alright guys, if you refresh your Dropbox, you'll see Dropbox in. Go ahead and give me your CPP file, and I'll make a Dropbox for the homework that I just discussed as well. Any questions? No? Yes, sir.
This, right here I have a int z equals 1, and then I have a while, and then parentheses z less than equal to 4. Not 5 for some reason. Should I change the int variable to a while?
Yeah, let me come look.